Hello, and welcome back to our training for students and professors and universities. This is our day 2, and we will be resuming our training from day 1 yesterday. My name's Alex Bacon, and I will be your trainer for today. I'm a technical support engineer, and I am joined with my moderator, Siska Choa, who is also a technical support, and we are located in Philadelphia, PA. If the control panel on the right-hand side seems to get in your way, you can show or hide this control panel, adjust audio settings, and ask questions at any time. For today's content, we will be going over the design add-on example, which I will go over what that will entail. Just a brief overview of what we did yesterday. Yesterday we went over the basic principles of FEA, and then we went into an introduction, on the program on REFM 6, and then we went through and modeled a continuous slab, and this included going over the best ways to enter in FE mesh, and also just how to model basic surfaces and members. And we also went over results, and I encourage you to check out that recording that is posted on our website from yesterday. So for today, this is the design add-on example, and the topics that we are going to cover are going to be load transfer surfaces, load case creation, some more element manipulation such as copying and rotating, and also the main topic will be the design add-ons. Then we will do some result interpretation of the static analysis, the timber design, steel design, and concrete design. So now I'm going to switch over to RFM, and we are going to use this model here. I'm going to open a previously defined or previously modeled model, and you'll find this model linked on the web page, the same web page that you used to register for this training or webinar. And I will also link a Google Drive link in the chat, and you can download this model from there if you would like to follow along and model along with me. So you can find that there and download it, and you can model along with me if you'd like. I would like to mention that I cannot stop and help you with any modeling issues, and if you have any questions, please post those in the questions section, and Siska will answer any questions that you have. And if there are any questions she deems worthy, not deems worthy, but if there's any questions she thinks that are best answered during one of our discussion periods, which is halfway through this training at an hour, and then there will be another discussion period saved for the end, then she'll save those till then, and I can go over them in RFM. So the first thing I want to go over with this model, I'll just go to a general overview. So this model is right now made out of concrete and steel. So you can see this gray color in the control panel is my steel A992, and that is basically this. I can highlight it. Material. So is steel A992 here, and then you can see I'm also using some steel A36 for these for the X bracing here. And then also we have some surfaces for my walls and slabs for my concrete. This is my concrete 4000 PSI here, along with some members, which are, I have my columns, and then I have my my beam, my concrete beam here, which is our rib member. Then you can also see that I'm using nodal supports and line supports to support the structure, using line supports to support the walls, and also using nodal supports to support these other member columns. I also have placed some openings in the walls here, so you can see these are acting as the windows, and I have used the opening tool for surfaces to place those windows there. So now, before we get into the modeling, I'd like to go over the base data. So what you can do, since this is a previously defined model, you can edit the base data at any time for a model. You can right-click on the name in the project navigator under the data tab to get to the base data, or I can go up here to the edit model base data button. So I'll click on that, and then you can see this edit model base data dialog box will pop up, and you can see here the name I have given this model already. You can also give it a model description, and this is a 3D model. Then next we have our add-ons tab. So this is the tab that Amy talked about, Amy discussed add-ons yesterday and how they work with the program. So basically RFM 6 is the base program, and then you can purchase a license for these add-ons for students and professors and universities. This is free, so you don't have to worry about that. You get access to all of the add-ons, but you can see we have some analysis add-ons, and then most importantly added is the design add-ons for concrete, for example, for concrete, steel, and timber. So concrete, steel, and timber is what the add-ons we want to activate because we want to design our concrete, steel, and timber today. So I'm going to activate concrete, steel, and timber. And that's basically all we need to worry about under the add-ons tab here. We can uncheck multi-layer surfaces. We're not doing that. And then we have our combination wizard and classifications check on. That means that we're going to generate load combinations according to a standard. And then we also have load wizards checked on here. We're not going to worry about that today, so we're going to uncheck that. And then we want to move over to our standards tab. Here you can see you can select your standard group for your load case classification and combination. I have mine set to the ASC 7, and more specifically the wood, which you have to have activated if you want to design timber. If you're not designing timber, you can just choose the regular standard. So we're going to choose the ASC 7 wood standard. And the difference between the non-wood and the wood standard is the wood standard brings out load duration parameters for load cases, and it also generates serviceability, the serviceability load combinations for wood. And if I edit this standard here, you can also see the creep factor is now activated for those serviceability load combinations, and you can change that here, and you can also change it in some other locations as well. We do have a long list of other international standards, so I'm just going to be, for example purposes, using the ASC 7, but we do have Canadian codes, Euro codes, and a long list of other ones. Then down here for the design standard groups, this is where you'll pick the standard for each design add-on. For concrete, for example, we're going to be using the ACI 318, and for steel, we'll be using the AISC 360, and for timber, we'll be using the NDS. Again, these are just for example purposes, so really we're just focusing on the workflow of how to use the design add-ons, really not getting into a lot of details on standards. So again, you can also change the units. I mentioned this yesterday, but you can change the units down here as well with this button. So you can switch them from metric to imperial by clicking on this load save template button, and you can switch from metric to imperial and choose the default. And then lastly, the last tab we really need to worry about, we're not going to go into these other tabs. The settings and options tab, I mentioned this yesterday. Global and local axes orientations can be changed here, along with some other options. So next, we want to go over, I'm just going to go over first we'll just get into modeling. So I do want to mention that this model is not completely realistic, and this isn't something that you would see being constructed. It's just strictly for example purposes. So what we want to do first is we want to take this substructure here, and we want to copy and paste it to the front of the structure and connect it and turn it into our timber portion of the model. So I'm going to go up here to our cube here, where we can change the orientation. I'm going to set the view in a top-down direction, and then I'm going to highlight this whole entire substructure here, and I'm going to copy and paste it. So I'm going to go up here to copy and paste, move / copy tool, and I'm going to create a copy, and I'm going to simply just move it pretty far over to the right in the X direction. I just want to move it make one copy and move it 40 feet in the X direction to the right. So I'll do that. And now we have that whole structure copied to the right. So I do want to delete this load case real quick. Sorry about that. And so now we have that copied over. And now what I want to do is highlight the whole thing. So if I drag from right to left, and everything that that box is touching will highlight all of those elements. And what I want to do is now rotate this. So I'm going to create a copy. Actually, no, I don't want to create a copy. Just want to rotate it. I want to rotate it negative 90 degrees about the z-axis. So there's two different options here. We're just going to use 1 point and a set of parallel axes. And that's basically how the program knows what to rotate about. And now I just gotta I can type in a coordinate point here, or I can graphically select one. So I'm gonna graphically select this point here. And then once I select that, I'm gonna click OK. And now this portion has been rotated. And now that that's been rotated, now I want to connect it, like this one over here, to our concrete slab. So what I want to do is, just like this concrete slab, or just like this portion here, I want to add some nodes to this line. And you can do this multiple ways. You can simply graphically add a node by snapping to the grid points that are located, they're lower down here. But you could graphically add a node to this line, or what we can do is simply just divide the line using our divide tool. So you can see when I hover my mouse over this line, you can see the orientation of the arrow. And that's telling you which way the line has been drawn, or the orientation of the line. I can also right click on it and turn on line orientation. And that's giving me the orientation of all the lines shown. So you can do that. And this is helpful because some aspects or some things that you define require the reference of the orientation of a line or member. So you can right-click on the line, and you can go up here to divide line, and you can divide it by a distance. And I'm going to divide the line from the end. So I'm going to divide it 3 feet from the end. And yeah, so you can either do it from the start or end. You can do it from using a percentage. And what I also want to do is check on this option down here to create nodes that are just strictly sitting on the line, and I don't want to divide the member at all, or divide the line at all. So I'm going to click OK. And so now we have our node here that's strictly just sitting on the line. You can see it's blue, so that's the online definition. And now what I can do is take this, highlight it, and I can drag and drop it right on that node, like so. So now that we have our structure on the node there, or I'm sorry, our structure connected to the the concrete slab here, even this portion here is also connected and integrated automatically into the surface. So we don't need to worry about that. Now what I want to do, this is still all steel. So what I want to do is create, if I look at my project navigator on the left-hand side, I want to create some new materials and sections, because we're going to just take these materials and sections and swap them out for timber materials and sections. And so what I'm going to do is go to section here, and I'm going to right click and click on new section. And then under new section, you can see I created a new section. It's just a concrete section, but what I want to do is import a new section from the library. And so you can see now our section library has popped up. We have our standardized sections built up, thin walled, massive, parametric, or just massive. So I'm going to choose a standardized section, and then I'm going to filter just to the United States, and I'm going to choose a post and timber section out of the standardized sections here. And this is going to be our columns. And I want to choose a 10 by 10. And now I need to create a material, or import in a material from our material library, because right now we only have concrete and steel. So I'm going to go down here and hit the drop down and click on new material. And so now now that we've created this new material, we need to import it in from our material library. So I'm going to go up here to the material library, and I want to filter. You can see we have many regions here for materials. You can filter to, for example, I'm going to filter to United States, and then I want to filter to timber, and then I want to filter to glue laminated timber, and I want to choose 24 for F 1.8, and then I'm going to choose looking back at my notes, I'm just going to choose the first one here and click OK. And keep in mind, in the material library, you can also just search for a material too. So you can clear this filter, and this also works for sections as well in the cross-section library. You can just simply search for the material that you'd like. So if I typed in A992, it'll go to A992. But let's just go back, to the timber. So I'm going to go back to glue laminated timber and choose 24, and we can choose this one. And so I'll click OK. And now the material has changed for the section that we want to create. Now I can click OK. And I will click OK again. But before I do that, you can also see, I just wanted to point out again, you can see the section properties here. You have some options here. Section values, you can see all your section values under this tab here, points, lines, parts, stress points. So lots of details given for each section. We can click OK. And now you'll see on the left-hand side here in the data navigator, I have now a new material under my materials here, and also a new section. So one thing you'll notice in the data navigator is that if a section or if anything is blue like this, that means that it's not defined or assigned. It's not assigned to any element within the model. So that's why this is blue. I don't have any members in my model right now that have this post timber section. So what we want to do is now we can simply just hold Control, and we want to turn these columns. We want to switch them to our post and timber section. So I just held Control, and then if you hold Control, you can select multiple objects. And then you can double click on any object to edit it. So that's what I did. I held Control and selected all of them. You can see when you hold Control, there's a little plus that goes next to your cursor. And to unselect an object, you can hold Shift and that'll unselect an object. So I'm going to select all of them and edit them. And now I'm going to go under the section tab here. And you can see that right now they're set to a W58, 8x58 shape, and the material is A992. What we want to do is hit this drop down, and we want to change this to a post to our 10x10 post and timber. And then you can see that material associated with that section is assigned. You get your graphic over here on the right hand side, and you get some display section details. You can hit display section details and you can see your section properties. So now I'm going to click OK, and all of my posts here, all of my columns here have been changed to that section. You can see it's not blue anymore. And now we just want to do that for the rest of our girders and joists here. So we need to create two more sections. And so I can just also, instead of just creating the section in the project navigator, I can also hold Control and select all of my girders here, double click on them, and then I can simply go to section, and then I can just simply click on import from section library. I'll go to my timber rectangles. And now I want to choose beams and stringers. Yeah, beams and stringers. And then I want to go to 4x14. Or, sorry, 8x12. Sorry, actually I want to go to dimension lumber, and then I want to go to 4x14. And I want to choose my timber material, my glue lam material, click OK. And it's asking me to assign the material again. Click OK. And so now those girders have been assigned to that timber cross-section and material. Okay, so now we want to do the same thing for our middle joists here. So we can just do the same order of operation section. We want to create a new section, and we can go up here and create a new. So we want to go down here to create a new section, and we want to go to import from section library and click on rectangular timber sections under the standardized portion. So all of these are from a standard, and we want to go to, again, or this time, beams and stringers, and we want to choose an 8 by 12. So we'll choose 8 by 12, assign the material, click OK, and we're going to choose that section that we just chose, or created, I'm sorry. Click OK. And so now we have our timber structure here. I can go down here to the display tab under the navigator, and I can change my colors of rendered objects, and we want to do that by object property, member, and then we can do this by section. So you can kind of just see a little bit better the three different sections in there. You can also just see that around the model, and the control panel on the right hand side here color coordinates all of those sections, and you can change these colors at any time. Okay, so now what I want to do is delete this when load case. Click OK. Sorry about that. Okay, so now that we have our timber structure here, I want to go over loading. So for this model, at the moment, I only have 2 load cases. I have dead and live loads. The dead load has no loading assigned to the structure other than the self-weight, which is automatically applied. You can uncheck and check this self-weight. And then for the live load, no self-weight is activated. You only want to have self-weight activated for one load case, or then you're taking self-weight into account multiple times, which is not good. But if I go under live load here, you can see I have a surface load here. If I double click on it, I have a surface load applied to the top slab of negative 0.02 KSF. And then we also have a load here applied to the steel structure. And this loading, you could just manually apply this loading to your members here using the member load tool. But what I did was, if I double click on these, double click on them, you can see I used the edit load wizard. I used the load wizard that converts area loads to member loads. And so all I did was give it a magnitude, tell it the distribution, the load direction, and then under geometry, I just chose 4 points. And so let me show you how to, and if, for example, if I right click on this and I uncheck display separately, you can see this was really just an area load that is 0.05 kips per square foot. And it takes that and uses the tributary area to determine the loading on each member here. I did neglect, or I removed influence from the two girders here. So if I want to do that same thing for this side, I can go up here to insert, and then I can go to load wizard, member loads from area load wizard, and dialog box. And then I created a new one. I'm going to keep it uniform, and I want it in the global Z direction. And I'm going to add a negative to make it face downwards. So it's going to be negative 0.05 kips per square foot. The geometry, so that's all we need to set for under the main tab here. There's some other options here, but we're going to ignore those. And then under the geometry tab, I want to select the four corners graphically. And I can do that using this button. So I'm going to select the four corners graphically, like so. 1, 2, 3, 4. And then you can see there's a thing or a section down here that says remove influence from. I can remove influence from specific member numbers, or I can remove influence from any members that are parallel to a member I select. So if I select a member graphically using this button, and I just select this member, any member parallel to this member is going to be removed from the loading. So if I click OK, now you can see that I have my member loads here that were converted from the area load, and I removed influence from those two girders. Okay, so that's the loading for our live load. So now what I want to do is create a new load case. So I'm going to go here to this button, create new load case. Keep in mind, any loading that you create in RFM has to be assigned to a load case. So that's all the loading assigned to our live load because I've selected live load at the top there in the drop down. Now I'm creating a new load case, and I'm going to name this wind in negative X. I'm going to make the action category set to wind load. And yeah, now I'm going to click OK. So now I just want to assign some wind loading to the structure. Let's say I want the wind. I want my wind load to be in the positive Y direction. I'm not sure why let's do positive Y. And now what we can do is start off from left to right here. So this first surface or this first wall is pretty easy. We can simply just add a surface load to this. So we can go up here to this button, new surface load. And this one is going to be 0.03 kips per square foot in the Y direction. So I'm going to click OK and apply that to that wall there. Select it graphically, you can see this box pops up. So I selected surface 4 here, click OK. Oops, I forgot to change. So right now, the loading is going in the positive Z direction. I'm going to double click on that. And we want to change the load direction to the Y direction. And that will look and make a lot more sense now. So yeah, now you can see that loading, that 0.03 kips per square foot or 30 pounds per square foot has been applied to our wall there. And now we also want to let's assume that there's going to be a window here. And if you want to take that window into account, you also are going to want to add an opening load to this opening. So we do have a tool for that. So if I go up here to this button and I hit the drop down and I choose new opening load, I can apply a load to the opening, and that's going to be the same 30 pounds per square foot. And I want that to be in the Y direction. It's going to be a uniform load distribution according to the global coordinate axis system. I'm going to click OK. And now this dotted line here, that's representing my opening. So I'm going to click that. And now my surface load or my opening load has been applied there for that opening. So that'll take into account if the wind blowing or the wind pressure applying to the window there. Now let's say we want to add that same exact area load to the slab here and the wall here and the column and all of this. And we don't want to do the calculations to just convert them to line loads and how that's going to distribute to these lines here. So what we can do is use what's called a load transfer surface. And a load transfer surface, oops, did not mean to do that. A load transfer surface is a different surface type from the standard surfaces, but it's still a surface nonetheless. So if I go up here to I can just click on, it's going to be a rectangular surface. I can click on new rectangular surface, and under stiffness type, I'm going to change this to load transfer. So we have other stiffness types for surfaces. We have without thickness, rigid, membrane, without membrane tension. I'm not going to go over these. The main two, standard and load transfer, are the ones that we're focusing on. Changing this to load transfer, you can see that now the thickness and material sections have been completely grayed out, and that's because a load transfer surface does not add any stiffness to the structure or any structural any structural component to the model. All it does is it allows us to apply a surface load to it, and then that surface load will be transferred into the elements that it is interacting with. So I'm going to go to the load transfer tab here. The load transfer direction is going to be, we're going to choose the X and local, X and Y directions. We'll keep the load distribution set to varying, and we don't need to remove influence from anything. So now we can click OK. You can see my cursor has changed to a reticle here, and now I simply just need to draw my rectangular surface. So I'm going to start from the bottom node here and go all the way to the second node, to the top node, to finish the rectangle. And now you can see my load surface has been created. It's red to denote that it's not adding any structural rigidity to the overall structure. And I also want to draw this same surface on our timber face here. So I'm going to draw that same one. And so now with these here, now we can easily add a surface load and this surface load is going to be in the Y direction, same magnitude, click OK. And I want to now select my surfaces, and there we go. Now you can see that area load, and you may be thinking, okay, can I check what the loading is now on my lines and members? If I go under the display tab here, and I scroll up, and I go under the surfaces drop down here, there is a display option to show loads from distribution surface. So I'll check that on. And you can see now what the loading is applied. I have my loading applied to the top slab. It's been converted to the wall there. And the same thing has happened with our timber structure here on the right hand side. So that's how load transfer type surfaces works. And that's all the loading we're going to apply for our wind load. The next bit of information I want to go over is the structure modification, or stiffness modifications. I want to go over how to apply stiffness modifications to a structure, for example, steel and concrete. For the American standard, for example, stiffness modifications are required to be applied to concrete and steel based on their individual standards. And so if you want to apply a stiffness modification, that is always done under the load cases and load combinations. So if we go up here to Edit Active Load Case, under the Load Cases and Combinations dialog box here, you can see under each individual load case there is a structure modification option. And so you can modify the structure for an individual load case. Under my load combinations tab here, you can see all my load combinations, and I have that also same structure modification checkbox. And then under the design situations tab, that same structure modification option can be found under the combination wizards section here. And this load combination wizard is used, the same one is used for our loads, our strength, limit state design, and our serviceability design situation here. And these design situations are basically what are creating automatically the load combinations. They are envelope solutions, and they calculate all of the load combinations and give you the maximum and minimum results. And so what we want is we want the stiffness modification we're adding to be applied to all of our load combinations and load cases. So under our strength design situation here, I want to edit the load combination wizard here. And then under our load combination wizard, you can see it's set to a second order analysis. So all of our load combinations by default and our design situations will be calculated according to a second order analysis, which is big P delta and little p delta. That's done automatically. But we want to check on this box here that says consider structure modification. And so what I want to do is edit this structure modification. I actually want to delete this one. So now what we want to do is we want to create a new structure modification. So I'm going to go down here to create new object. Basically, it creates a new structure modification. You can see there's a bunch of options here. We're mainly going to focus on materials and sections, and what we want to do is modify the stiffness for our members. So I'm going to go to members, hit the members tab, and you can see under the members tab, we have member modification, members. So for the member modification, this is what we're going to be choosing the type of modification we want to use. So I'm going to just click on new member stiffness modification. I'm actually going to delete these previously defined ones. So now you can see we created a new stiffness modification. And under modification type, we have a list of modification types you can choose from. We have one where you can just apply an overall multiplication factor to the total stiffness matrix. You can choose a stiffness modification factor for axial, bending, shear, or torsional stiffness. But for steel, we want to choose, since we're using the American standard, we want to choose the AISC 360 latest version. And now you can see that tau B is going to be calculated based on equation C, chapter C 2-2A. This is for our LRFD design method, and our bending and stiffness multiplier factors are automatically applied here and assigned. So we'll click OK. Sorry, excuse me. We'll click OK, and now we need to tell the program which members we want to apply this stiffness modification to. So we can either type that in the members we want to assign this to with our keyboard and type in the numbers of the members, or we can simply click on this button here to choose them graphically. So I'm going to just simply highlight all of my steel members here. And you can see those are entered up here in this box here. I'm going to click OK. And yeah, now you can see those are entered. And I am going to then create another stiffness modification for our concrete members. So I'm going to choose the ACI, columns, click OK, hit members, and now I want to choose my concrete columns, like so. Then I'm going to create another one for our beam. Click OK. I'm going to select the concrete beam graphically. So yeah, that's how you can apply stiffness modification to members. Then we can also choose surfaces and create stiffness modifications for surfaces. So I already have some created here. I'm just going to choose flat plates and flat slabs. And I'm going to choose my surface there. Then I'm going to choose walls uncracked and select my, select my walls here. So there we go. Now I have all of my stiffness modifications created, so I'm going to click OK. And keep in mind that if you need different stiffness modifications for either LRFD or ASD design situations, you can create multiple load combinations and just change them like so. So let's say now I needed to create a stiffness modification for my steel members specifically for ASD. I would have this same, I can create a copy of this same stiffness modification, go to members here, and then I just simply want to change my steel members or my steel modification to switch this to ASD, click OK. OK again, and now I can go to my ASD design situation and choose this other load combination wizard that I created. Then for this design situation 3 here, this is our serviceability design situation specifically for timber. As you can see, it has our creep factor in it, and it has our serviceability load combinations from the ASC 7 for wood. We don't want to apply this to our concrete design or steel design. This is only for timber. So yeah, that's basically how you can create stiffness modifications within RFM. So I'm going to click OK. And now we can run the results. So I can hit my drop down here and you can see all of my results. And I'm going to hit calculate all. I'm not sure what this error is referring to. Member number, beam, strange. Okay, so we're going to hit calculate all. And now it's going to run through all the iterations, take advantage of multi-threading, and run through all of our load cases and combinations. You can see we have concrete, steel, and timber down here. Those aren't going to... We don't have anything assigned for those, so no need to worry about those really. But our static analysis has run. And so now you can see we are looking at our global deformations at the moment. And so yeah, we can view our global deformations. You can see we're under our serviceability design situation right now. We could go under our LRFD design situation, and we can take a look at, since it's an envelope solution, we can take a look at our maximum values and our minimum values. Our maximum values right now, we're getting a deflection, a maximum deflection of 1.14 inches. And you can see that this timber member here is deflecting very high. But we have our control panel on the right-hand side here. Under this second tab in the control panel, we can see our deformations factor. This is showing our graphical deformation 32 times what our actual deflection is. So you can adjust that. You can see how much that's exaggerated for this single member. One other thing I forgot to mention during the modeling process, if I turn my results off here, is I forgot to add in our member hinges. So you can see for these two members here, there are these white dots that are on the end of them. Freaking power. You can see these two white dots here on these represent member hinges. And so if I double click on one of them, you can then see that I'm editing this member, and right now I have the hinges option turned on. And when this hinge option is checked on, this hinges tab here will pop up. And this is where you can edit the member hinges for your member. And this affects the connections of that member. And so right now, if I edit this member hinge, they look very similar to the support definitions for nodal supports and line supports. So right now you can see that the phi, y, and z is checked on. That means that the rotation about the local y and z axes is released. So moment transfer from this member is 0, basically, except for torsion, which is about the local x-axis. And so what I want to do is it's going to ask me, what I want to do is also apply these these hinges to our other members here for timber. So I'm going to double click on them, check on the hinges option, hinges, and I want to use the same hinges. And so then I'm going to double click on these members here. And I also want to add hinges to the start and end of them. There's already hinges at the start or the end. I'm going to add them to the start. And now you can see we have hinges, member hinges, at the ends of all of our members except for our columns, because we have 4 members framing in to this one connection, and at least one of them has to be fully fixed or we'll get an instability when we try to run our calculation. Okay, so we can run our calculation again real quick. So, okay, very sorry about that. So that's what it looks like when there's an instability. And so what I just did was I just simply removed those hinges for now. Something with the structure probably can't handle the loading with those hinges I applied. Very strange. So I decided to remove the hinges for now. But anyway, we can rerun the calculation. And now you can see we're looking at our global deformations. You can see most of them come from the timber structure here. I'm under the wind load, but if we go under strength. So If I highlight this whole thing and I hide selected objects, then we can get a better view of our deformations in other places, such as our concrete here. We can also check on member results too. So we can view our internal forces for our members, so the axial forces, shear, axial, moment for all of our members. Then for surfaces, we can also take a look at the stresses on our surfaces, so basic stresses. We have equivalent stresses for von Mises. That's mostly for steel, not really for concrete, really. We can take a look at the internal forces for our surface here and check out those. We can add values on the surface. And yeah, so those are kind of all the things you can check out in the static analysis, which you can see is what we're under up here. All of this is also organized in the table. If you want to know the maximum, if you want to know what load case or what load combination is causing the maximum deflection or something, or not something, what the maximum displacement is, you can see that load combination associated with that. And so now now we can get into the design add-ons. So now that we've run our static analysis, now let's say we want to design our timber over here. So if we want to design our timber structure, then what we would want to do, again, is go into the general data, add-ons, make sure timber design is checked on. And for this example, I'm only going to be, so I'm going to not show results anymore. For this example, I'm only going to design these two timber members up here, member 53 and member 54. You can turn on member numbers by right-clicking anywhere and hitting show numbering. And so now that we have, now that the timber design add-on is checked on, we want to hit Control and select both of our timber members here. And we want to make sure design properties is turned on. So we'll check on design properties here. And then now we just want to work from left to right in these tabs. And so with the design add-ons, all of the design parameters for each member are located in the member editing itself. So I want to go under design types here, and under design types is where we can set things like effective lengths, service conditions, and local section reductions. We're just going to focus on effective lengths. So I'm going to hit this drop down and create a new effective length. And this is where you can see, you can check on or off what you're considering effective lengths for either buckling about the strong major axes or the minor axes, or you can check on or off if you don't want to consider lateral torsional buckling. For this member, lateral torsional buckling for a rectangular member is really not a concern, so we can uncheck lateral torsional buckling. And then under null supports and effective lengths, we can set our boundary conditions here. So to get a better idea of what our boundary conditions are, we can click this button and switch between a static or dynamic image for this graphic over here. So if I click this button, now we can see that we can see our members here that we're designing and how they're connecting. And so basically our start and end nodes here, we're looking at up here, so start and end. You can see that at our start nodes here that we're fully fixed in the Z direction and in the Y direction. And the same thing goes for our endnotes here. Now, if you really want to just skip this part, you can just type in the k-factor down here, as well as entering in the absolute value of the effective lengths down here as well. So now we'll click OK. Yes, we want to continue. So now our effective lengths are set for that member. Now we can move into design configurations, the design configurations tab. Here is the strength configuration settings, so we can edit those by clicking on this little hand here. And under our edit strength configuration settings, you can see there's some options here. I'm not going to go over any of these, and I'm going to leave them as default. You can also see there's some further tabs up here for further options that you can change. So you can edit your factors here for timber, your load duration factors as well. And then we have some serviceability configuration settings. So if we edit these for serviceability design, you can see you have your beam limit, your L over for beams it's L over 360, and the deflection limit for cantilevers is L over 180. And you may be thinking, okay, the program probably automatically knows if something is a cantilever and something is a beam for design. It doesn't know that for the design add-ons. So under this last tab here, design supports and deflection, if you leave this alone and you don't touch anything under this tab, the program is going to assume your member is a beam. If you add in just one design support, then it's going to, that's how it knows it's a cantilever. So this is how it knows whether to compare the deflection to the limiting deflection you set for a beam or a cantilever. I'm not going to go over any design support settings or anything like this. So we're just going to click OK. Yes, I want to continue. I'm going to turn off show numbering. And so now that we entered those design parameters for those two members that we want to design, now mostly, if not all, the design add-ons are viewed in the tables. So you can see here in this drop-down static analysis, you can see we have concrete design, steel design, and timber design. So if I click on timber design, now I'm under the input data. And so under the input data, I'm under design situations, the design situations tab. And so we have our design situations, all three of them here. We do not want to use the strength or the ASD design situations. So we're going to uncheck strength limit state ASD design situation number 2 here. We want to use the serviceability design situation for timber, and we also want to use LRFD strength limit state design. So these are the two design situations we're designing according to. Let's move left to right in these tabs down here. So objects to design. We don't want to design any surfaces. These are all concrete, obviously. We don't want to design all members, so we want to uncheck design all. Under select objects, we want to choose them graphically. So we'll click that button, choose our two members there graphically. And now what we can do is here's materials, sections. This is all imported in. We don't have to redefine any of this. You can see the materials and sections in red are obviously materials and sections you can't design for that. So now what we can do is hit show results under the timber design here. And now you can see we get our results. So right now we're viewing our timber design. This is the first tab, design ratios by design situation. So you can see design situation 3 here and design situation 1, and we get all of, you can see our member numbers, location, which loading is our controlling loading, the design check with our design ratio here. We're passing with flying colors, very low design ratio here. And then you get each of your checks here, basically design check type. So what you can do is you can see, for example, this section proof is bending about the local y-axis according to section 3.3. And maybe this one's over the design ratio check, so you're wondering, okay, what's going on? You can double click on any of these checks and this dialog box will open up and you can see what you want to show on the left hand side here. And then you can see you get all of the design check values along with equations and reference checks from any of the codes that you're using. And then you can see all of the equations on the right hand side. So this is very helpful. We like to be very transparent with how RFM is calculating everything. And so what you can do is you can go in and you can check any of these. You can also just click on one and click on this button here, design check details. And you can see all of the values and all of the equations and code references that we're using. So feel free, if you see anything that you don't agree with, feel free to email us and we can always check on them, and we encourage you to do that. So that is timber design. You can also view, so if I click on both of these members and select both of them and create a visibility by selected objects, and I turn off show objects in the background, you can see we're showing the design results graphically. So I have design checks turned on. So these are our design checks on member, max of all values. So basically I'm seeing the maximum design check values as a diagram on the member. And you can see our maximum design check 0.42 is from our serviceability design check. You can also do this for strength limit state and choose which code checks you want to show graphically. We can also check out mode shapes as well if I turn off that. I'm actually a little unsure why that's showing. We'll skip that for now. I must have a setting turned off. Okay, so that's it for timber design. And so now I want to move on to steel design. So I'm going to cancel my visibility here. And now I want to design these two steel members. This is very similar to timber design. My steel design add-on is checked on. And now I simply just want to design these two members. And these two members are going to be a little more interesting for steel design because I have my design parameters checked on. And then we want to start under design types. And these two are interesting when it comes to effective lengths because, so we want to design these members according to the ASC 360. And we can keep on flexural buckling about the major and minor axes, torsional buckling, and lateral torsional buckling. For lateral torsional buckling, for determining the elastic critical moment, you can do that according to an eigenvalue method or according to chapter F from the ASC 360. The eigenvalue method is a theoretical method for calculating the elastic critical moment. It's not taken from any standard. It's using eigenmodes to do this. But if you want to calculate this according to chapter F, that's an option. So then under the nodal supports and effective lengths, these two members are more interesting than the timber ones because they have their start and end conditions, which are very similar. It's fixed in the z and y axes and about the x axes for the start and end. But you can see we have these joist members framing into the seal girders here. And so we need to take these into account. So you can see we have these nodes here on our members. And so what we want to do is check on intermediate nodes, and we want to use these nodes to our advantage to define these effective lengths. So we want to use this button here, select nodes, and we're going to select our nodes here. And sorry, actually we want to insert the 2 new rows first. And inserting those 2 new rows automatically detects those nodes. So you don't need to select them graphically. If you hit insert rows twice, since we have 2 nodes for each of these members, then you can see the node numbers here, 45, 47, and 46 and 48, which are there, are automatically selected. And so then at those nodes, they're framing into the y direction. So for these, they are fixed in the y direction at those nodes. And it's also up to you basically if you think that these are restraining torsionally about the x-axis. So you can check those on as well, but they're not framing vertically into those girders, so and the z directions, we want to leave those released. You can also adjust the size of these nodes. These orange nodes are just representing the effective lengths. So we'll click OK. So now you can see that. Then design configurations, this is similar to timber. We can edit these. You can see there's some other options under here. Web crippling. Yeah, so we don't need to change anything under there. Some stability options, serviceability configuration. This is showing your limiting deflection ratios for your beam and cantilever. And lastly, the design supports and deflections tab. If you leave this blank, then your member will be considered a beam. If it's a cantilever, then you would want to add in a design support for whatever side it is that is a cantilever, or else the program will just reference it as a beam and use the beam serviceability deflection ratio. So we can click OK now, and then we can go under steel design. And we want to keep checked on strength limit state and serviceability limit state for our LRFT and ASD. Also very similar to timber, we want to go under objects to design and choose our 2 members here. We have our materials and everything. So now that's basically everything for steel design. We can click calculate. And so then we get our steel design. So similar to timber, the only main difference for these 2 members was the effective lengths that we did. And so now we can move on to concrete design. And so I'm just going to design for concrete these 3 concrete columns. Oops. Unselect that. So we're going to double click on them. We already have our concrete design add-on chosen. And so now we just want to turn on the design parameters for these members. And so the first tab we're working with for concrete design is the effective lengths. For concrete design, if you create effective lengths or set effective lengths, this will use the moment magnification method. And we don't want to use the moment magnification method, so we're not going to set any effective lengths. The next tab is the concrete cover, which for this example is going to be 0.5 inches. Then we have our shear reinforcement. Excuse me. So for shear reinforcement, we want to choose the stirrup type. And so under stirrup type, you can see that we have a bunch of stirrup types. We're just going to use the first one for now. And then the material here, yours is probably not set. I'm using grade 60 for the reinforcement, for the rebar. So what you can do is go under new material. I'm sure yours isn't set, so go under new material. And under the material library, you can, I'm just going to choose all. You can go to reinforcing steel, choose your region, reinforcing steel. For me, it would be ACI 31819, grade 60. So that's how you would choose your reinforcing steel for your rebar. And then bar size. Here we want to choose the bar size. We're going to choose 4. And yeah, that's, oh, number, let's make this 17. Okay, we'll keep that at 13. That looks good. The length of our column there. You can choose the distance between them, like so. So if the distance, something like that. Yeah, so you can see how this works with creating a layout. You can also choose a start and end for the layout. So start and end. And so what that allows you to do is create multiple spans here. So you could have different shear reinforcement at different locations. You could put more shear reinforcement at the start and ends of the member, since the shear forces at the start and end would be a lot higher than the middle. So you can do that on the right hand side here. I'm just going to keep it general and uniform for the whole thing. There we go. So now we want to move on to longitudinal reinforcement. So for longitudinal reinforcement, you can choose symmetrically. This is a column, so we want to choose probably uniformly surrounding. And we would have our longitudinal reinforcement in the corners there. Bar size, number 4 is good. And I'm sorry. Let's choose some number. We'll have 4 number 8s. So 4 number 8s for our bar size. And then you can see things like reinforcement area. And again, you can have different you can have certain parts or certain spans having different longitudinal reinforcement by creating multiple items over here on the left hand side. Then also you can choose an offset type, an anchorage type as well, so hooked, bend. Yeah. Design configurations, strength configuration. There's a lot of options under here that I'm not going to go over. Serviceability configuration is very similar again. Actually, it's pretty different for concrete. Sorry about that. So a lot of options here. You can see you have your deflection analysis, crack analysis, crack detection. So you can adjust your crack width here as well. So lots of options. And then your design supports and deflections. So we'll click OK. Go to concrete design. You can run that. Not sure why only oh, okay, so we chose, I forgot to go to the input here and change this. Members, we only want to design those columns. Whoops, so forgot to choose the columns that we're only designing. That would make sense why we got a lot of errors there, probably. Did I? Yeah, okay, so let's try just running that again. Can't design steel as concrete, so, or timber, so that makes sense. Okay, much better, yeah. So this is our concrete for all 4 of our columns there. You can see the reinforcement is in the rendering. We get our design check ratio graphically there. You can see our highest design check right here. And again, you can click on these, double click on them, and see exactly what the check is and all of the equations and everything. Okay, so that's concrete design. And oh yeah, I also wanted to mention you can check on, so if we let's say go to our axial strength and combination for flexural checks, axial and flexural checks according to 22.3 and 22.4. Any of these checks you can check on the interaction diagram, and you can then see this tab up here pop up and you can get a look at the interaction diagram. So this is very handy. Yeah, very useful. So that's there. And now the last thing I want to go over is the printout report. And so if you want to create a printout report, you can go up here to this button, current printout report. Here, I'm just going to shrink these a little bit. This button here, sorry, not current. This button, new printout report. And so here is the printout report manager, which you can use before you actually generate the printout report. You can give it a name. So I'll call this University Days. And you can see here you can choose or turn on and off things that you want to show. So right now I just have members and my member joist turned on under basic objects. So there's a lot of customization when it comes to your printout report. And so you can turn on and off elements that you want to see and don't see in your printout report. I can collapse this. And so let's say under timber design, you'd want to see your strength configuration settings. You can have those turned on. For results right now, we're only going to show the design ratio on members by member. Design overview, we want some graphics. You can add and subtract graphics. I'll show how to do that. You can also hit this button and you can customize your header here. So you can turn on and off the header, and you can also change your the logo here, which you can select your logo, save locally on your computer by clicking on these 3 dots, Then you can edit the cover page here in this tab as well. So lots of options here for the printout report. So then I can hit print, and then the printout report will be generated. You can see the status of that down in the bottom left-hand corner. Any statuses are going to show up there. We can save this printout report as a PDF. So University Days PR, and save that anywhere on your computer. Put that on your desktop. And then it will generate, you can see it's generating the printout report down here at the bottom. Okay, so once the printout report generates, then you can see it. So on the left-hand side here, we have our navigator, and you can click through these chapters. You can see I have all my materials here, sections, thicknesses, all of the basic objects like that. If I right-click here, I can collapse all of these. So then you can see how this is organized. We have our steel design section here, so objects that we're designing, design situations, materials, strength configuration settings. Then we have design ratios on members. So you can see member 20 here, the design ratios, the checks, the chapter checks, and whether they passed or failed basically. So yeah, that's kind of, and you can take these and organize this any way you want. You can move them around. It's nice because this printout report is a whole separate window, so you can keep this on a second screen if you'd like, and it'll constantly update. You can also, when you're creating printout reports, I'm sure it takes a while to get them just the way you want them. So what you can do is you can save a printout report as a template. So I'm going to exit out of this. And so I'm going to hit new printout report. And so once you have all of this information checked the way you want it, you can save it as a template, and then you can load save templates, and you can see here all of the different templates that I have saved. And so once you get your printout report looking the way you want it to, then you can, and it's similar to all of your projects, you can simply just open a load save template. And then even these additional page settings, such as your header and logo and everything, you can also save these as additional templates as well. So good to know. Also, if you want to add graphics to your printout report, you want to go up here to the print graphics to printer. And you can hit print graph, or you want to select print graphics to printout report. So you can hit that. And then under here, you can get a preview of what that's going to look like. You can do a current only print, which takes the current view that you're seeing now in your graphical window and sends it to the printout report. Or you can do a multi-print, which once selected, you can see you can send multiple images that are generated automatically by the program by what you've selected in here in these tabs, and it'll send those to the printout report. For example, if I wanted to see in the X direction, the positive X direction, the loading for load cases 1 through 3, for example, here you can change this. I'm sorry, actually this will just show the model in the X direction. Under loads here, you can change the views and send graphics from specific loading and directions that you've chosen, and you can do the same thing for results and add-ons. And then back under general here, you can choose the picture size and rotation. And then there's some additional picture qualities and additional options. Again, you can save templates for this too. So that's basically the end for today's training. So I thank you guys all for coming out. And I encourage you to check out our website where we have a lot of really great in-depth resources on anything you're looking for, really. I really highly recommend checking out our webinars under videos and recorded webinars, newsletters. We have lots of events and conferences, and plenty of knowledge-based articles and FAQs that I recommend checking out for anything you're looking to do. Here's our phone number and our email. I highly recommend emailing us at our tech support email here. We will respond to any questions you have, any modeling issues you have. You can send in your model and we will take a look at it for free. So thank you again, and I hope you have a good rest of your day or night.